Okay, welcome everyone to Stephen Follows Instructions, part 3 of Protégé. I've been doing a little bit of digging in Protégé and also an associated product called Web Protégé. Experimented with that, made an account on the Web Protégé site, also got a Docker container running with Web Protégé on my own desktop. I wonder if I can show that. It might be running. I don't. Yeah, it might be running. Let's see. No, it isn't running at the moment. Probably because Docker isn't running. That's okay. So, there's the right screen with pip. Is that better? No, I still can't see. Right screen. Right screen pip. I can't seem to capture my video on that anymore. Well, just having issues with issues with my camera and that, but nothing major. It's just it's annoying. It's just because of the setup I have here. Anyhow, so anyhow, as you see, it's not running. I would have shown that on Stephen Follows Instructions yesterday, but I had to start and stop and start and stop my computer. Something with my Windows subsystem for Linux got glitched, and so Docker for Windows Desktop isn't running with WSL anymore. So I've set it so that it's running with Hyper-V. That seems to be working for now. So, but anyhow, well, it bothers me now. This is what happens to me, right? These things bother me. That's not it. No, it isn't running, is it? No. Okay, well, I'm not going to worry about that. So anyhow, that's what I did over the last few days, and it's been a pain. I also looked for APIs for Protégé, didn't find any. But what I want to do today, remember last time on the videos, I was working with the pizza example, and it went horrible. That's because the pizza example was for an old version of Protégé, and the Protégé I was using was the current version. So, of course, nothing matched up. I found a new pizza Protégé tutorial. So, here it is. It's nice and big for you. I'm just going to make that smaller. There we go. It's actually the same size, but there we go. So I'm going to use this now, and this one starts at the beginning and goes all the way through and explains all of the concepts, and it looks to me like it'll be really a lot more use. So that's what I'm going to do. It really bothers me that I can't have my video here. So I'm going to remove it and try to load it again. Video capture device, add existing video capture device. Okay, there we are. Now you should be seeing me down in the corner, or maybe I'll put myself, I'll put myself here. There, that should be good. All right, so that's much better. Okay. The world's most boring video. Put it on like 2 times speed, 4 times speed, whatever. Okay, I love this, right? It had, he says, the long version of the pizza tutorial had minor inconsistencies. Well, no. There were not that trivial as we found out. So anyhow, let's go to it. The latest tutorial can be found here. So here it is. A practical guide for building OWL ontologies using Protégé 5.5 and plugins. So this is the revised version, etc., etc. So lots of contents. This one's a lot longer, a lot more detailed. We'll figure out what we're doing here. So this has people. Okay, so there's a mailing list that you can go to, which is great. And then the overall. Okay, look at now how he's going to do his instructions. So we have some conventions. So anytime you see highlighted text, it refers to something that you should or optionally could view or enter into the user interface. Often the text you enter into a field will be the name of a class, property, etc. In those cases where the name is meant to be entered into the field, it will only be highlighted rather than highlighted and printed in console as font. So, okay. All right. Oh, I have a cat that wants to get out. Hang on. Sorry, kitty. Good kitty. Bye-bye. Yes, working with cats. All right. I love this. Examples are presented like this. Exercise, do this, do this, do this. Pitfalls and warnings, tips and suggestions, explanations, general notes, vocabulary explanations, etc. Nice, clear conventions. I like that. Okay. Requirements and the Protégé user interface. So you must have Protégé 5, which we have. Set up into a series of tabs, etc. Each of the tabs consists of various panes, or as Protégé calls them, views. Each view can be resized. Okay, so this is the stuff that we covered before. Have Protégé. Let's get it up and running. Here it is. There we go. Took a little bit. So there are the tabs, there are the panes, etc. So, yeah. Protégé calls them view. But it should call them panes, right? View has a certain meaning. Okay. I really hate that pop-up sort of. Should be a better way to read this. There we go. That's better. And all right. Whoops. And now it's gone. There we go. All right. Okay, so let's get back to where we were. Sorry, I just hated all those things popping up on the screen all the time. Oh, I'm just going to pause my audio here for a second. Hello?
Hi, good afternoon. This is Stephen.
Speaking.
Hi, Stephen. This is Allison with the Ottawa Hospital.
Yes.
Family Health. Calling to remind you about your appointment for tomorrow.
Okay. So, yeah, the perils of doing live video, right? So, such is life. Um, so, just the usual, just plain ordinary. Yes, you have a doctor's appointment tomorrow. Will you be there? Yes. And okay, let's do the COVID thing. So, but I don't have COVID and haven't had COVID, etc. Okay, back to our video. Um, so, chapter now here he's going to do something a bit different from what we saw before. He's going to explain what the whole thing is about. So, what are OWL ontologies? So, ontologies capture knowledge about some domain of interest, describes the concepts in the domain and the relationships that hold between those concepts. Different ontology languages provide different facilities, and here we're using OWL from the World Wide Web Consortium. I think it stands for Ontology Web Language or something like that. OWL makes it possible to describe concepts in an unambiguous manner based on set theory and logic. Very important. Complex concepts can be built out of simpler concepts. The logical model, and again important, allows the use of a reasoner which can check whether all the statements and definitions of the ontology are mutually consistent and also recognize which concepts fit under which definitions. The reasoner, therefore, can help to maintain the hierarchy, and it is a hierarchy, correctly. All right. So, this is particularly useful when dealing with cases where classes can have more than one parent. The reasoner can also infer additional information. For example, if two properties are inverses, only one value needs to be asserted by the user, and the inverse value will automatically be inferred by the reasoner. Okay. So, an OWL ontology consists of classes, properties, and individuals. So, this kind of makes sense, right? OWL ontologies are an implementation of description logic, which is a decidable set of first-order logic, right? A class in OWL is a set, a property is a binary relation, and an individual is an element of the set. Other concepts from set theory are also implemented in OWL, such as disjoint set, the empty set, or nothing, inverse relations, transitive relations, and many more. An understanding of the basic concepts of set theory will help the user get the most out of OWL, but not required. One of the benefits of Protégé is that it's probably a new paragraph here, is that it presents an intuitive GUI, that's debatable, that enables domain experts to define models without a background in set theory. Okay. However, developers are encouraged to refresh their knowledge of, not on, of logic and set theory, and we get a reference. Okay. Individuals. Individuals represent objects, or I would say entities, in the domain of interest. The big difference between OWL and most programming and knowledge representation language is that OWL does not use the unique name assumption. That means that two different names could actually refer to the same individual, just like in the real world. For example, Queen Elizabeth, the Queen, and Elizabeth Windsor might all refer to the same, now sadly deceased, individual. In OWL, it must be explicitly stated that individuals are the same as each other or different from each other. So, and here we have a representation of some individuals. And down below, we have some properties. So, Biswanath and India are individuals, and Biswanath is related to India by the property lives in. See, I would call that a relation rather than a property, but yeah, I'm being picky here. Okay. And Biswanath is related to Michael by the relation has friend. So, yeah. And yeah, I could quibble about all kinds of things. Now, individuals are also known unhelpfully as instances. Individuals can be referred to as instances of classes. Okay. Properties. Now, this is important because this isn't the way we normally think of properties. Properties are binary relations between individuals. Okay. That is, properties link two individuals together. You can see that there's a relation between all of this stuff and the stuff that I've done. Not surprisingly, because it's basically the same field. For example, the property has friend might link the individual Biswanath to the individual Michael, just like we've seen. Or the property has child might link the individual to Michael to the individual Oriana. Properties can have inverses. For example, the inverse of has child is has parent. So notice the inverse isn't contrary or contradictory or anything. Inverse is something quite distinct. If you think of an arrow pointing, from one to the other, the inverse is the arrow pointing in the other way. Okay, they can also be transitive or symmetric. Right. So like the property near or near to is symmetric. If A is near to B, B is near to A. Transitive, if A is near to B and B is near to C, A is near to C. Okay. Properties are similar to properties in object-oriented programming. Not really. However, there are important differences between properties in OWL and OOP. The important difference is that OWL properties are first-class entities that exist independent of classes. See, that's, anyhow. OOP developers are encouraged to read, and there's a reference. So, classes, now, I'd call them types, maybe, or categories, but rigorously, we're going to say classes are sets that contain individuals. We should say that may contain individuals because we could have a class which is the empty set. They are described using formal mathematical descriptions that rigorously define the requirements for membership of the class. For example, the class cat would contain all the individuals that are cats in our domain of interest. So that's not exactly rigorous, but we'll leave that aside. Classes may be organized into a superclass, subclass hierarchy, which is also known as a taxonomy. Pretty familiar to most people, right? We have the class of cats, and that's part of the superclass of animals, and that's part of the superclass of living things, etc. Subclasses specialize, or we can say are subsumed by their superclass. For example, consider the classes animal and dog. Dog might, not necessarily, dog might be a subclass of animals, so animals is the superclass of dog. This says that all dogs are animals, all members of the class dog are members of the class animal. That categorical reasoning is really important, and of course that goes straight again into set theory. All right. OWL and Protégé provide a language that is called description logic, or DL for short. One of the key features of DL is that these superclass-subclass relationships can be computed automatically by a reasoner. Right. Figure 3.3, is that this? Yeah. Shows a representation of some classes containing individuals. So here we go. Here's a class of countries. USA is an entity of that class. Mike, here's a class of person. Michael is an entity in that class. The individual Michael lives in the country USA. So what we're missing here, and this is, like I say, this when they say properties, they're using it in a way that seems different for me. You know, if you want to say something like Michael has red hair, right? You'd think of that as a property of Michael. But, you know, technically, you might say it as things that have red hair is a class. And then, I don't know. I don't know how they deal with that. I don't know. See, I want Michael to have just... Well, see... Because I'm also thinking of databases, right? And, you know, you have these properties, hair color. I don't know. Just bracket it and continue. Okay. In OWL, classes can be built up of descriptions that specify the conditions that must be satisfied by an individual for it to be a member of the class. How to formulate these descriptions will be explained as the tutorial progresses. Okay, so that's useful though, you know, defining their terms like that, because that way, you know, we're not going to be misled by, well, everyday meanings of these terms. Okay, now we're on to doing things. Yay. Start Protégé. Oops, automatic update. Start Protégé. Okay, Protégé is started. When Protégé opens for the first time each day, it puts up a screen of all the available plugins. You can bring this up at any time by using File, check for plugins. You won't need any plugins, so just click the Not Now button. Interestingly, that's exactly what I did. You just saw me. The Protégé interface consists of several tabs, such as active ontology, entities, etc. Let's check that. Okay. Whoops. Rats. Okay. See, and again, this is Java. It doesn't have quite the same feel as a regular Windows program. Okay. Active ontology, entities, etc. When you start Protégé, you should be in the Active Ontology tab. You are. This is for overview information about the entire ontology. Protégé always opens with a new untitled ontology that you can start with. Here we're up to an untitled ontology 17. Your ontology should have an IRI, which is like a URI, only different. And okay, there's is 27. Edit the name of the ontology and change it to something like Pizza Tutorial. Okay, edit the name. The part after the, okay. How? Oh, here we go. Ontology IRI. All right, we're going to call it Pizza Tutorial. Tutorial. Okay, is that going to be big enough? Not really, eh? Let's see if I can't make things bigger. Yes, there we go. All right, so that's a bit bigger. I'm going to make things a bit easier. Okay. So, and here's where I edited it. And I have to keep in mind that my head is there. There we go. So we'll just make sure I'm not putting my head in front of the screen. All right. Note the pizza IRI shown below. Show the IRI after I edited the default Protégé generated for me. Your I will look different and be based on the name of your own organization. In my case, my username STEPH. I don't know why it's that on my own computer. Okay. So far, so good. If you want to save now you want to save your new ontology. Select File, Save, and choose a format. There's a drop-down of menu of formats. The default RDF XML syntax should be selected by clicking the OK button. This should bring up the standard dialog your operating system uses to save files, we hope. Give it a name, something like Pizza Tutorial, and press Save. So let's select File, Save. So File, Save. Okay, here's the default RDF XML syntax, which is what we're using, and click OK. And now we're going to save it somewhere. I'm going to save it in Code Project, Web Protégé, and I'm going to call it Pizza Tutorial. I assume that it'll put the extension on for me if I need one. We'll find out. Alright, and select Save. And now I've selected Save. Very good. As with any file you're working on, it's a good idea to save your work at regular intervals so there's no autosave. That's what this is saying without saying it. There's no autosave. Okay. The next step is to set some preferences related to the names of new entities. Remember that, typo. Remember that in Protégé, any class, individual, object property, data property, annotation property, or rule is referred to as an entity. Okay, so that's how they use the word entity. Okay, the term name in OWL can actually refer to two different concepts. It can be the last part of the IRI, in other words, the URL, or it can refer to the annotation property, usually RDFS label, used to provide a more user-friendly name for the entity. We'll discuss this later below. For now, we just want to set the parameters correctly so the future parts of the tutorial, especially queries, will work appropriately. Okay. So, next exercise. Set the preferences for new entities and rendering. Go to File Preferences in Protégé. This will bring up a new window with lots and lots of different tabs. Click on the New Entities tab. It will bring up a tab that looks similar to 4.1. The top part of that is a box labeled Entity IRI. It should be set up with parameters. Okay. If the last parameter is set to auto-generated name, change it to user-supplied name. Okay, so let's do that. File Preferences. File Preferences. Okay. Go to the lots and lots of tabs. Go to the New Entities tab. Here it is. It's kind of hard to see the black text on dark gray, but that's just a usability thing. Ends with, right, so start with the active ontology IRI, followed by a pound sign, and then end with, and here we're going to have user supplied name. And if it's changed to auto-generated name, change it to user, and it wasn't, so we didn't. Okay, now select the renderer tab. It should look like 4.2. Renderer tab should look like 4.2, and it's going to be down below a bit. Check that entity rendering is set to render by IRI short name ID. So it's not. So I'm going to check that rather than render by annotation properly. Don't worry if this doesn't completely make sense at this point. The issues here are a bit complex and subtle. Okay. So, but smart. Making sure that we've got these things right. I assume we click OK now. I'm going to click OK. So there's the New Entities tab. There's the Renderer tab, which we just looked at. And we're using the Render by IRI short name, right? Right. Okay. Figure 4.3. The active ontology tab with a new comment. So let's go back to, okay, we're in the active ontology tab. Don't have a new comment yet, but I assume that's what's coming up here. Enter a comment annotation to your ontology. Okay. Make sure you are in the active ontology tab. In the view just below the ontology IRI and ontology version IRI fields, find the annotations option and click on the plus sign. Okay. Make sure you are in the view just below ontology IRI and ontology version IRI. Okay, right here. Yeah, see annotations, tiny little text there. Click on the plus. Okay, and that's going to take us into a menu to create a new annotation on the ontology. The RDFS comment annotation should be highlighted by default. If it isn't highlighted, click on it. It is highlighted. Okay. Then type a new comment into the view, in other words, into the pane or into the form to the right, something like a tutorial, etc. Okay, so it doesn't say whether it should be literal or property values or anything, does it? Okay, well, we'll just put it in here under literal. Click OK. See, we can choose some things here down here, even the language, but we're not going to worry about that. And there's the comment. Tutorial. Okay. And is that what happened with them? Yes, it's exactly what they got. All right. Okay. Next, named classes. Okay. The main building blocks of an OWL ontology are classes. It's our properties. Or more, not properties. No. See, this is where I get confused, right? They're sets. They're like categories. See, I'm used to sets or categories being defined as things that have certain properties, right? Like they've just had animals, birds, whatever, right? But I'm used to sets being, things that are blue, things that have four legs and bark. You know what I mean? I'm familiar with defining sets by properties rather than just making them as this plain unarticulated building block. Now, later on we'll get how we define these sets, but I need to be careful about that. Okay. The main building blocks of an OWL ontology are classes. In Protégé 5, editing of classes can be done in the Entities tab. The Entities tab has a number of subtabs. When you select it, the default should be the class hierarchy view as shown in figure 4.5. So let's check. Entities, class hierarchy, OWL, thing. Right. So that's what they have, except now they have pizza. So All empty ontologies contain one class called owl thing. Owl classes are sets of individuals. The class owl thing is the class that represents the set containing all individuals. Because of this, all classes are subclasses of owl thing. Right. So, okay. Oh, this is interesting. Each of the subtabs in the entities tab also exists as its own major tab. In the tutorial, we will refer to tabs like the class hierarchy tab or the object properties tab, and it is up to you, the user, whether to access them from the entities tab or to create them as independent tabs. Right. So I could have up here, I don't know if I can just drag, no, of course you can't drag anything, but I could have this tag of classes, or this tab of classes, as a major tag or as a sub tab of entities. I think that's what it is. Okay. So active ontology is kind of like the metadata for our ontology, at least as far as I can see. Entities now, this is our classes. All right. And then some other tabs. Okay. Okay. Good. Navigate to the Entities tab with the class hierarchy view selected. Make sure owl thing is selected. Okay, navigate to the Entities tab with the class hierarchy view selected. It is recall under the classes tab. Okay. Make sure owl thing is selected. All right. Press the Add Subclass icon shown in figure 4.4. This button creates a new subclass of the selected class. In this case, we want to create a subclass of owl thing. Subclass. Is that this? Add subclass. Okay. Okay, oh yeah, add subclass and add sibling class or delete class. Okay. Alright, so add subclass. This should bring up a dialog titled Create New Class. With a field for the name of the new class, type in pizza and then select OK. So add subclass. We'll call it pizza. Notice the IRI is auto-generating down there, and click OK. There are new entity options as well. Right, that's that preferences page that we looked at before. Okay, and now we'll click OK. Voila, we have created a pizza. Repeat the previous steps to add the classes pizza topping and pizza base, ensuring that owl thing is selected before you add the subclass. Okay, well this is interesting. So we're not making pizza topping and pizza base subclasses of pizza. We're making them their own classes. Okay, pizza toppings and pizza bases. Pizza topping and pizza base. Alright, so new class pizza topping. Okay. Oh, that's not what I wanted to do. Control Z. Yes. Alright. Make sure owl thing is selected. Okay, pizza topping. And select owl thing again. Pizza base. Alright. So, pizza base, pizza topping, pizza. pizza base, pizza topping, pizza. So, okay. Whoops. Go away. All right. Okay. Don't worry that some of the classes are highlighted in red. That's because the reasoner hasn't run yet. We will address that shortly. Now, interestingly, mine aren't in red. So, but I haven't run the reasoner, so there's a bit of a difference. All right. Moving along. Okay, the entities tab is a big tab that has tabs like classes, object properties, data properties, etc. Subtabs. Each of these subtabs is also a major tab, just like before. It can be created on its own. Since I took screen snapshots at various times, I wasn't always completely consistent. All right. Sometimes I use classes as a subtab, sometimes as a major tab on its own. At different points in time, I had other tabs open depending on other work. Therefore, your UI won't look identical to the figures, etc. All right, fair enough. At least he explains that, and that's helpful. There are no mandatory naming conventions for OWL entities. Probably just as well. We'll talk about that in Chapter 7. The best practice is to select one set of naming conventions and then abide by that convention across your organization. For this tutorial, we will follow the standard where class and individual names start with a capital letter for each word and do not contain spaces. Camelback notation, in other words. Okay. Using a reasoner, you may notice we haven't. Okay. Protégé has not been able to verify that our new classes have no inconsistencies. Right now there's little chance. However, it is a good idea to run the reasoners often. When there's an inconsistency, the sooner it is discovered, the easier it is to fix. Yeah. Common mistake new users make is to do a lot of development and then run the reasoner only to find there are multiple inconsistencies. So let's get into the habit of running the reasoner often. Okay, fair enough. Since we are going to run some swirl, don't know what that stands for. Standard web rule language? I don't know. We want to use the pellet reasoner. It has the best support for swirl at the time this tutorial is being written. Okay. Install and run the pellet reasoner. 1. Check to see if the pellet reasoner is installed. Click on the reasoner menu. At the bottom of the menu there will be a list of installed reasoners such as Hermit and possibly Pellet. If Pellet is visible in that menu, then select it and skip to 3. Okay, so click on the reasoner menu. Here's the list. Okay, if we have 2 versions of Pellet, Pellet and Pellet Incremental. Okay, we'll just select Pellet. And, okay. All right. Now, I had trouble with plugins last time. So, this will install. Let's see. All right. Well, let's just assume we're okay. But let's flag this. If the reasoner breaks for some reason, here's where the instructions are to install it or to reinstall it. Okay. With Pellet selected in the reasoner menu, execute the command reasoner start reasoner. Reasoner start reasoner. Okay, just like before, we don't see anything. The reasoner should run very quickly. you will notice that the little text message in the lower right hand corner of the Protégé window is now changed to say reasoner active. Okay, you can't see it. Ooh, I'll just make this smaller so you can see it. There it is, reasoner active. Kind of hard to see that. Whoops. Alright, so back to where we were. Okay. Okay. The next time you make a change to your ontology, that text will change to say reasoner state out of sync with active ontology. So again, okay, with small ontologies it runs very quickly, so it's like save. I guess there's no auto reasoning, just like there's no auto save. Okay. It is possible that one or more of your classes will still be highlighted in red after you run the reasoner. If that happens, do A. Window refresh user interface, and any red highlights should go away. Okay. When your reasoner seems to show you something you don't expect, the first thing to do is to try this command. Alright. One last thing we want to do is configure the reasoner. By default, the reasoner does not perform all possible inferences because some can take a long time. So, but we will always be dealing with small and simple ontologies, so we want to see everything a reasoner can do. So let's click on Reasoner Configure, Reasoner Configure, and here's our screen. A bunch of different things. Alright, so bring up a dialog with several checkboxes. If they aren't all checked, then check them all. Okay, checking all the boxes, and then I assume click OK. He doesn't say that, but I think that's a fair assumption. So I'll click OK. And we did not get a warning, but just went back to the main thing. Alright, doing good. Disjoint classes. Having added the classes pizza, pizza topping, and pizza base to the ontology, we now want to say that these classes are disjoint. That is, no individual can be an instance of more than one of these classes. In set theory terminology, we ran into this yesterday, or the other day. The intersection of these classes is the empty set. Owl, nothing. Right. So how do we make these disjoint from each other? Select pizza in the class hierarchy. Find disjoint with option in the description view. Description view. There it is. Again, it's hard to see, so I'll just move this so you can see it. Alright, so I've selected pizza. Here's the description view, and here it says disjoint with right here. Alright. Select the plus sign, see the red circle in figure 4.6. Okay, so I'll select the plus sign. Right. And we get this little interface coming up. Okay. Let's just cancel that so we can keep reading. Okay. This should bring a dialog with two tabs, class hierarchy and expression editor. You want class hierarchy for now. We will use the expression editor later. This gives you an interface to select a class that is identical to the class hierarchy view. The interface is identical to the class hierarchy view, not the class. Use it to navigate to pizza base. Hold down your shift key, select pizza base and class topping, select OK. Alright, did you get that? I think I got it. So, I'm going to go disjoint with. I'll go down here. Just clicked on that arrow. I'll select pizza topping. Okay, doesn't say how to select both, but usually pressing Control selects both. That's what it does. Okay, so I had to press the Control key to select both. Click OK. And we see it's disjoint with pizza topping and pizza base. Alright. So let's come back to the instructions. Do a reasoner, synchronize reasoner. Then look at pizza base and pizza topping. You should see that they each have the appropriate disjoint axioms defined. So that's interesting. See, here's pizza base. Oh, it's already got... Oh. Okay, it's already got these things. But okay, reasoner, synchronized reasoner. Alright, so it already had these things. So this actually synchronized on its own automatically. So maybe the reasoner did sort of run quietly in the background. I don't know. But I wouldn't count on that. So yeah, you do something like that. You run the reasoner. That brings these up to date. You should see now. Oh, hold down. Okay, he said hold down the shift key. All right, same thing, different tool. Select OK. All right, good. Right, there's the red circle. OWL classes are assumed to overlap. That is, by default, they are not disjoint. This is often useful because in OWL, multiple inheritance is not discouraged, nor should it be. If we want classes to be disjoint, we must explicitly declare them to be so. It's often a good development strategy to start with classes that are not disjoint and then make them disjoint once the model is more fully fleshed out, as it is not always obvious which classes are disjoint from the beginning. Like take citizenship, for example. You might be tempted to make Canadian and American disjoint, but what about dual citizenship? Right? So, better to wait. Okay. Using create class hierarchy. Okay. In this section, we will use tools, create class hierarchy to create multiple classes at once. Enter hierarchy. Okay, so this is interesting. Ah, yes. I remember this from before. The create class hierarchy wizard. So, select. So here we're going to, okay. Select the class pizza base in the class hierarchy. With pizza base selected, use the tools, create class hierarchy menu options. So select pizza base, and now select tools, create class hierarchy in the menu option. Here's the what we were just looking at. Okay. You should see a window labeled enter hierarchy, which we do, where you can enter one name on each line. You can also use the tab key to indicate that a class is a subclass of the class above it. For now, we want to enter two subclasses of thin and crispy base and deep pan base. One of the things the wizard does for us automatically is to add a prefix or suffix, so we'll just enter thin and crispy and deep pan, and then in the suffix we'll add base. Okay. He hasn't said whether to use the tab key, but I'm pretty sure we use the tab key here. Alright, so thin and crispy and deep pan. Okay, so the suffix is base. And I don't want to actually have it base, so we'll remove that. Now, I think that if I just enter it like this will just add stuff. So I think what I need to do here is use the tab to indicate that these are subclasses of pizza base. So let's hit continue. Do you want to make sibling classes disjoint? In this case, we do. So we'll leave it checked and we'll click finish. And you see we've now created deep pan base and thin and crispy base. And the red indicates that the reasoner hasn't run on those yet. Select continue. This should be checked. The base can't be both deep pan and thin. Just like, and now synchronize the reasoner. Okay. So we'll synchronize the reasoner. So reasoner, synchronize reasoner. Yeah, it's sort of half worked. So there. Don't know why it couldn't change the entire color of the thing, but oh well. All right. Moving on. Won't be going too much longer because it's getting to the end of the day here. But I'm enjoying this a lot more than I enjoyed the other tutorial, believe me. And I'm going through it really slowly and narrating as I go along. And yeah, pretty much memorizing it by doing that. So just a bit of a study tip for you there. All right. So I continue, etc., etc., and this is what we have. Similarly, create a pizza topping hierarchy. So we're going to create a more interesting hierarchy with additional subclasses. Okay, so we're going to do the same thing. Pizza topping. We're going to create a class hierarchy. We want all of our toppings to end in topping. And then create the nested structure as shown here. See that? Oh, no, that's interesting. I wish I could just copy that and paste it. There's no way, eh? No. All right. So, okay. I thought you would have had to... Yeah. All right, well, that's fine. So this will take a few moments to do, but... I'm just going to leave that there so I have something personally to refer to. All right, so pizza topping, tools, create class hierarchy. Okay, here we go. Cheese, mozzarella, parmesan, meat, ham, pepperoni, salami, spicy beef. Seafood, anchovy, prawn or shrimp, tuna. Are there tuna pizzas? Vegetable, caper, mushroom, whoops, forgot to indent that. Olive, oh, it didn't indent again, okay. Pepper, and we have red pepper, green pepper, and jalapeno pepper. Yeah, I know, jalapeno. And then finally, tomato. And then the suffix is topping in every case. And we'll continue. They will be disjoint. And we're going to get our result now. See? There we go, etc. And so now we'll run the reasoner. Synchronize reasoner. And everything will be good. Beauty. Beauteous. Beauteous. All right. So far we've made some simple named classes and subclasses. What does it actually mean to be a subclass of something? In OWL subclass means necessary implication. That is, if vegetable topping is a subclass of pizza topping, then all instances of vegetable topping are also instances of pizza topping. Sure. It's for this reason that we try to have standards such as having all pizza topping classes end with the word topping. Aha. Otherwise, it might seem that we are saying, I talked about this before, that we are saying that anything that is a kind of ham, like the ham in your sandwich, is a kind of meat topping or pizza topping, which is not what we mean. For large ontologies, strict attention to the naming of classes and other entities can prevent potential confusion and bugs. All right, good explanation of that. Do I agree? Irrelevant. Okay. Let's just look at what we need to do here. All right. I'm going to call it here for today. I'm going to come back to this. This is progressing really well. So we've left off here at the end. I'm going to start up again in 4.6 OWL properties and continue on from there. We've done really well. I'm going to save file, save. That'll save my ontology, so it'll be there for next time when we go to do this. And so that's it for Stephen Follows Instructions. Nice, clear instructions. I like that, and I'm feeling really confident now that whatever I try to do based on these instructions is going to work. So probably putting in another couple of hours, 2 or 3 hours, based on what I've seen so far on this tutorial, and I'll have a really good handle on this program, how it works, and how to use it to do stuff. So, and me being me, I always get a step or 2 or 3 steps ahead of myself. I want to be able to have a web-based interface where you input something like, I want a spicy pizza, and it gives you suggestions as to topping combinations, something like that. Or whatever. But that's getting ahead of myself, and I don't want to get ahead of myself. So until next time, thanks for being with me. We had one viewer for approximately 1 minute. Not even. Average view duration, 14 seconds. All right. So, talk to you all again